My name is Dara. I'm a software engineer at Spotify, and today I'm going to be giving a talk on React's concurrency and how you can use its features to optimize performance within your application. So before we get into the talk itself, I just want to give a bit of background into my journey in front end and how I got here. So my journey started about 2017. After university, I started learning HTML, CSS, and JavaScript. And I basically did that using, I didn't do any kind of formal course. I just would practice, download templates online and tear them apart, put them back together again. And over time, I found that I was gaining and developing the skills. And then I moved to my first full-time job in tech in 2018. And that was kind of when I started to become introduced to front-end frameworks as a whole, and then more specifically React. So I worked in a bank for a few years from 2018, and then in 2021 I moved to, still within the finance space, I moved to a cryptocurrency trading startup. I was there for a year, and then in 2022 I got my first full stack role at Spotify. So up until 2022 I had always had solely worked in front end, and then today in my role I basically write both back end and front end, and on the front end is React code, and then on the back end I write Java. So yeah, that's a quick summary of my journey. So here's a quick agenda on the topics we're going to cover today, starting with the concurrency problem in React. So why are we talking about this? Why is it why does concurrency exist? And then we're going to do a deep dive into some of the concurrent features that were introduced in React. I'll talk through some use cases and then some drawbacks, because as we know, there's always drawbacks. And then finally, we'll just summarize, go through key takeaways, and then move on to Q&A. So the performance challenge, if we think about the most important factor when it comes to user experience, I think the first thing that would come to a lot of people's minds is probably rendering. That is from a development point of view. So the faster the rendering, or the faster an app renders, the better the feeling of that app is for the end user. And over the years, the applications we build have become increasingly complex. So there's more data that these applications are handling, there's more user interaction, there's more real-time updates. And if you think about the apps you use on a daily basis, like Instagram, Twitter, or even like an e-commerce platform, all of these applications deliver information to you basically at the speed of light, right? So we're always getting this immediate feedback from applications. And essentially with all of this complexity comes, that also translates to more renders and more computation on the application side of things, and essentially more burden on the performance that application is under. And then, so this is kind of where React's concurrency comes in. So I broke this up into two, the what and the how. So I'll go through the what first, and then we'll look at the how. So before I get into that, so just to define what concurrency is, it's basically the ability to handle multiple tasks at once. For example, rendering the user interface, handling user inputs, and also processing network requests, all at the same time without blocking the main thread. So before React released version 18, the render process was synchronous, right? So that means that once rendering started, React would block everything until that rendering was done. So we had to wait until React was finished before it could handle other events. Now, what concurrency has done is it's basically made that rendering process interruptible. So we can interrupt that rendering process because it's processed in chunks and not all at once. And I'm gonna show a quick example of this in a second. But concurrency essentially makes for a more fluid user experience, and also just a more efficient use of a system's resources, because we're managing multiple tasks at the same time. So I think just to add even more context, this is like a summary of concurrency and how React has gradually adopted this feature or this concept within the framework over the years, or over several versions, starting with version 16.8. So hooks were introduced in this version, and it was quite a, like I said, a major game changer in terms of memoizing components using a hook like useMemo, and also changing how we manage states and side effects in functional components. React also introduced Suspense specifically for lazy loading in this version. React 17 was basically about ensuring backwards compatibility with earlier versions. And then onto the main topic of conversation here, React 18. And this version is when concurrency really started to take shape. So initially, React introduced an experimental mode, which then became just concurrent rendering. And as you see on this slide here, we can see that the three of these features I've highlighted here, transitions API, use deferred values, batch updates, as well as suspense, are basically kind of like a summary of concurrency, but more specifically, the transitions API, use deferred value, and suspense. So automatic batching or batch updates is basically React grouping multiple state updates into a single render, and then thus like reducing the amount of work that it has to do. In this version, React also improved Suspense, which means that Suspense is now supported for server-side rendering. And then Transitions API and use deferred value, which we're going to look at in a second. But essentially, this version was really major because it changed how we think about rendering in React. So again, like I said, this is kind of the comparison between pre-version 18 and post-version 18. So the top image shows you the rendering process when it was synchronous, and the render process is broken up into two. So it's typically, or it's always the render phase and then the commits phase. So the render phase is when React will calculate the diff between the existing component tree and the current component tree and then the existing DOM, and then basically determine what updates need to be made. And then the commits phase is when React will actually apply those updates to the DOM. So as you can see in the first image, this process is synchronous, right? We see that rendering happens in one long single block. And again, that just means that nothing can interrupt it until it's done. And then after that process is done, we have the commits phase. So it's all done in one large task. And this means that there's a likelihood that the UI can freeze. So if my component is rendering and I click on a button, for example, that button is not going to respond because React is still in the render process. And then at the bottom, we see concurrent rendering, which is asynchronous rendering. And essentially, what this has introduced is that React is now a lot more intelligent, so it can pause the rendering process, handle a more important task, and then go back to the less important tasks, all before actually hitting that commits phase. So we see that instead of one continuous render block, the render is divided into small chunks, which we can see represented by the blue boxes. And React does this by basically pausing at brief intervals. So it's every 5 milliseconds. And what it does is it checks whether there's a high priority task that needs to be completed. By high priority, that could mean any user interaction that requires immediate feedback. So the click of a button, typing into an input field, or even scrolling through the page, for example, right? So React will prioritize those critical updates. And then once those are done, it then goes back to continue rendering the less critical updates. So these are essentially the building blocks of concurrency. So this is how concurrency works under the hood. And yeah, I thought it's important to kind of know how this is happening, just to give you more context, so that as you use these features, you can also kind of have these in mind. So fiber nodes, starting with that's basically the foundation of the concurrency model, and it's a data structure that represents the component tree as a set of fiber nodes, and each node contains information that React needs to compute and render that component. So things like type, state, props. And then time slicing, which was actually the initial name for concurrent rendering, is essentially just the foundation of how this works. So instead of processing the render as one long block or chunk, React breaks down that render process, or the work is broken up into small manageable chunks or slices. And React enters this loop where it keeps checking for and processes these fiber nodes incrementally over multiple frames instead of processing everything all at once. So by breaking down this work into slices, React can then allow the browser to handle other tasks, and then that ensures that the user interface stays responsive. And then the task scheduler is sort of like the engine, if you think about it like that. So this is what manages the execution of these tasks, and it uses a priority queue. So it determines which updates should be processed first, and then when to pause or stop an update entirely. So the scheduler essentially is intelligent enough to know, okay, this is a high priority update. This is more critical than a low priority update, which could be fetching data, or say like displaying a list of results from some kind of user interaction, right? So those are essentially deferred and deprioritized until the higher priority tasks are done. So the balance between this urgent and non-urgent tasks is what ensures that the performance remains smooth and the user interface stays responsive. And then finally, yielding. So again, all of these work in tandem, right? So they're not entirely separate. So yielding is essentially the act of yielding control back to the browser in that time when React has paused this rendering because there's a more high priority task. So if a task is a high priority task, such as a user interaction, or if the task is becoming expensive, the scheduler will basically yield control to the browser, which means that it's saying, hi browser, handle this task. I know that it's it's a higher priority task. So handle this task so that the user interface is not blocked for this user. Once that process is done, then I'll continue and I'll take over again. So it's a very interesting sort of process, and especially how all of these work together. So now that we understand essentially what concurrency is, how it works behind the scenes, we can then actually talk about the concurrent APIs in React. And yeah, this is essentially what you're going to be interacting with or using within your applications. So all of these rely on the building blocks that I've just shared, and they've kind of been abstracted away. All that process has been abstracted away from these public APIs. So firstly, I'm going to be talking through three major concurrent APIs, or the three main ones that were introduced. First, transitions, and then useDeterredValue, and then Suspense. So starting with transitions, like I just shared, React or concurrency in React is basically being able to handle multiple things at once. And in order to do that, it determines what's high priority, what's low priority, which is what the scheduler does, right? So what transitions allow us to do is, transitions are basically a hook. So React introduced the useTransition hook, and it allows us to assign a priority to updates. So we can prioritize critical updates and deprioritize non-critical ones. And so we can see here in this example, the useTransition hook, it returns two things. It returns an isPending flag, which is true or false, and then a startTransition method, which we then use to wrap a low priority update. So whenever something is wrapped inside a startTransition, like you can see here, it's considered a transition update, which is also essentially a non-urgent update. And so the other updates on the page will take precedence over this one. So in synchronous rendering or before concurrency, all components had the same priority and every update was considered urgent. But now we can actually assign a specific urgency to different tasks. So there are two ways to use transitions. We can either use the hook, the useTransition hook that we have here, or we can just call this startTransition method directly. So import this directly from the React library and then use it here. The added benefit of the hook is that we have the flag, so if we wanted to conditionally show or hide some kind of loading states, we could do that. I'm going to demonstrate all of this in practice, so it'll hopefully make more sense to you. And then, so next up, we have deferred values. So again, this is in the form of a hook called useDeterredValue. And what it does is it takes in a value and returns that value. So it takes in the value that you would like to defer. And by defer, that's basically, I want to delay the rendering of this value until the browser has processed more critical tasks. So it takes in, the parameter it takes in is that value that you would like to defer. And this is very useful when it comes to essentially values that aren't immediately critical to the user experience, right? Like I said, if you want to render some kind of visual elements that's not going to affect the UX or any kind of non-essential data. So as you can see here again, I have an input field, and that has an onChange handler that's setting a value. And then over here, I have a paragraph tag that's actually displaying that value. So again, the top task will take higher priority over the deferred value. This will be handled first, or this render process will be handled first before this one. So again, very similar to transitions, but this allows you to defer a specific value, while the useTransition hook allows you to defer a state update. And then finally, Suspense. So again, if you've been using React for a while, you've probably come across this. Use this to lazy load a component. And then the added benefits that React has included in version 18 is that Suspense now can support server-side rendering, which means that I can pause or suspend rendering a component until some asynchronous operation has completed. So again, I'll kind of show this in practice so it'll make more sense. And the benefits of this is that the slow parts of the application don't drag the fast parts back. And one thing to kind of note here is that you need to avoid, or you should avoid, suspending your entire application. So wrapping your entire app within Suspense, because that could actually have a counter effect and lead to a poor user experience. So now we have the demo. Hopefully this works super smoothly. Okay. So I'm going to kind of show before and after. So I think that's, a good way to demonstrate the effectiveness of these concurrent features. So I have an application here. It's just basically a small app that has different artists. These are not my favorite artists, just a random set that I chose. So we have 3 artists here, and as I switch tabs, I can see the artist bio, right? So that's essentially what this application is doing. I have my main app, which is displaying the tabs. So I have the tab here, the div tab here. Then I have this artist's bio component that's actually displaying the content within that tab. I'm also using a fake API, which is from the React official docs, and it's essentially just returns this generates a random time value. So here, creates some kind of delay. So it's mocking what an API would actually do. And then I have my loader, which is just loading some text that says loading. Now, the main issue here is that, notice that as I'm switching between these tabs, the loading state is there until that content renders, right? So it works, but it could be a much better experience, right? Where I don't have to keep seeing this loading state. And in order to achieve that, we could actually use concurrent features. So let's go to the next page. Oops. Sorry about that. Yes, here. Okay. So the demo I just showed you was the non-concurrent version, right? We switched to the tabs. We saw the contents, but because that content is being loaded from a fake API and it's taking some time to load, then we saw that loading state was there for a while. And then we have this concurrent version where we click and then the tab does not actually switch until our data has rendered. So how are we actually achieving that? As I mentioned before, actually I'll start with Suspense. So this basically uses Suspense and the useTransition hook to achieve that, to achieve this user experience. So as I mentioned before, Suspense allows us to actually suspend the loading of a component, or rather suspend the loading of the data within a component, because it now supports server-side rendering, right? So if I wrap any components within Suspense, I can keep checking whether that data has loaded, the data within the component has loaded, whether it's like resolved or rejected or thrown some kind of error, and then I render a fallback until it has completed. So previously we would lazy load those components, but now what we're doing is we're actually suspending the data that the component requires, or rather suspending on the asynchronous loading of that component. So instead of suspending on the asynchronous loading of the component itself, we're suspending on the asynchronous loading of the data within that component. Yes, that's correct. And as we can see here, we've wrapped our tabs inside Suspense, and this artist bio requires a resource, which is essentially the data. And because the artist bio is within the Suspense, as you can see, that component doesn't render until that data is done. But this doesn't work on its own, right? It works with the useTransition or the useTransition hook. So what I've done here is I have basically deprioritized the act of setting the tab and setting the resource. This calls the data that I'm using to display my, or data, this fetch data is fetching data within that tab. So by wrapping these two things inside startTransition, what I've done is basically I have deprioritized these. So I'm saying don't prioritize the act of setting the tab or setting the resource until Suspense has actually received the asynchronous data that it requires for artist bio to load. So all of these work, or these two concurrent features work in tandem. And you can see that as I switch the tab, the act of setting the tab and setting the resource doesn't change because those are transition updates. And when I switch, Suspense basically waits for that data to be loaded from the server, quotes unquote, and then that tab switches. So it's again, just to kind of show you how what these have. This is the tab content, and this time here is the resource coming that the component wrapped inside Suspense relies on. So if I go back to the main page, I have my Suspense component and it's wrapped inside artist bio. Artist bio relies on resource, and resource is coming from here, right? So here I'm calling it on the initial load of the component. I'm calling this fetch data, and then I'm setting that resource as part of the transition update. Yes, so essentially that's how, or that's one benefit of, or one use case of concurrency within React. And then just also demonstrate how the useDeterredValue hook would work. So again, I'm just have a fourth tab here for artists. And essentially, if you notice, as I'm typing this in, I'm typing as I speak, there's a UI freeze. And this is one of the major kind of use cases when it comes to concurrency. So because the render process is basically rendering this list, and for additional context, this list has been artificially slowed down just to kind of demonstrate what it would look like if in a real world application where you have some kind of data loaded from the backend. But as you see, as I type, the inputs does not actually load, or it's freezing, so it's taking some time, and that's because React is completing this render process. So what if I switched to use the useDeterredValue hook? I have it here, it's taking in that text that I'm typing in, and instead of displaying the text itself, I'm using the deferred query here, right? So I'm passing in, or I'm deprioritizing the rendering of these names and prioritizing this one by using this hook in this way. So as I type now, I'm typing and there's no freeze, and that's because the inputs on change set text here is taking priority over my deferred query value here. So again, a good kind of demonstration of the benefits of how just the idea of React kind of yielding control to the browser to handle a more high priority task and then deprioritizing the less critical ones. Okay, so running through the use cases now, starting off with what we just saw, switching between tabs and kind of using useTransition and Suspense in tandem to make that work the way it did. But that's one example of many. Another example would be prioritizing user input. So if you had a search field and you had a list and you were searching through for a specific value within that list, that's another way that you would use. That's another way that you would use React concurrency, basically to say prioritize what I'm typing into this input field and then deprioritize whatever is being loaded, or the search results essentially. Because again, if you think about it, the user does not need immediate feedback when it comes to what they're searching for. You could show some kind of loading state. And then also for things like animations, so using more fluid animation, or achieving more fluid animations by deferring certain updates that might interfere with the animation's timing. Just another point here on this previous prioritizing user inputs point is that before we would have relied on something like debouncing to handle this, but concurrent features like startTransition, we can now prioritize inputs processing over these other tasks. So we do have that as an alternative, but this just makes it a lot easier and like less code to write. Some drawbacks, of course, there are always drawbacks. So with concurrency, when it comes to non-urgent updates, you might still experience some delays, and that's because React has to yield control back to the browser frequently. So like I mentioned, every 5 milliseconds. So although the interaction is smoother, it could introduce some delays when rendering the less critical updates. And then another one is that it also doesn't help with expensive components. So it doesn't necessarily solve the issue of super slow components, right? Because if it takes a long time to render a component, say it's 500 milliseconds, then it's going to render that component within that time frame, even if that component is marked as a non-urgent update. So regardless of whether I'm using concurrency or not. And then finally, which is kind of like a major one, is that all the work that React is doing in the background, so the amount of complexity required to kind of use the scheduler and yield control to the browser, all of that adds a strain on the CPU. So there's actually an increase in CPU usage with concurrent rendering over traditional synchronous rendering. And I like this quote from the Solid.js author. I see the value of concurrent rendering from an I/O perspective. I just haven't seen it from a CPU perspective. So yeah, that kind of backs up the idea of just like an increase in CPU usage because of the amount of complexity that's been added to the library to achieve concurrent rendering. So just to summarize some key takeaways, concurrency allows React to render multiple versions of the UI simultaneously. it's also not enabled by default, so it requires you to explicitly opt in. And by using any of these concurrent features like use deferred value or use transition, then you're using concurrency. And then finally, it doesn't make your application faster. What it does is it makes it feel faster by improving the user interface responsiveness. Thank you so much for listening. And yeah, happy to take any questions.
Hi, Dara. Thank you so much for your talk. It was so interesting. I still can't wait Monday to talk with my colleagues about your idea and implement it in our project. Can you hear me? Okay, so our question is from Valeria. Hi, what are the limitations of React's concurrency features, and are there specific cases where they might not be suitable?
Just to kind of summarize, it's still possible to build performance applications without concurrency. I think concurrency is good for very specific use cases. So for example, if you have, like I said, if you have a search field that's loading like tons of data and you notice that the UI freezes as a user is typing, that's because there's some kind of block on the main thread. You would use one of those concurrence features, right? So to kind of keep your application responsive. But again, it's important to be aware of how you're using these features because it could actually have a counter effect where if you overuse them, then it could just lead to a poor user experience and also kind of I think it requires some kind of knowledge of how React is working internally so that you can use them as efficiently as possible. Because if you have a better understanding of how these concepts are working behind the scenes, then you have better you're able to control when to use them and when not to use them. And then if you think of like a case of say a user is using a low-end device or processing lots of super intensive tasks, then concurrency might not actually have any kind of significant performance benefits. So I would say it's particularly useful when it comes to just improving perceived performance of an application.
Okay, thank you for your answer. And our next question is use defer value better than the bounds? Like it's also the bounds value when making async operations like fetch?
I wouldn't say it's better. I think it would just depend on the use case that you have. So specifically use deferred value is when you want to delay the rendering of a value on your page. So like in the demo, if there's a list that you have and you don't necessarily want the user to see, it's not important or it's not critical for the user to see that information immediately. They don't require any kind of immediate feedback and there's something else on the page that's triggering a re-render that is more critical, you would then use deferred value. So I think the bounds you use it when you want to kind of limit the frequency of like say scrolling or like an API call, but use deferred values. I'm specifically deferring, like making the UI more responsive for the user. So I don't know if it's better or worse. It's just a different use case, if that makes sense.
Okay, thank you so much. And our next question is, thank you so much for your talk. What tools and techniques can be used to debug and profile the performance of concurrent React application? How you can identify potential bottlenecks and optimize your code?
Yeah, that's a good question. So I could have actually included that in the presentation, but one of the main tools you would use is the Google Chrome DevTools. So there's a performance tab, and you can just profile the page and record user interaction. So if you have an example, a concurrent, non-concurrent example, and a concurrent example, and compare those within Google Chrome, once you hit record and you say type into a field, then you stop the recording, you can see how React process, like the entire render process and how React is rendering those components or basically how the browser is handling the page. So with a non-concurrent example, you would notice that the tasks are much longer within the I guess the browser, or that tab within the performance tab in the browser. Whereas with the concurrent example, you would notice that those tasks are much smaller, and it also shows you like the timing, the amount of time it takes to load each of those frames, and it's significantly more with a non-concurrent example compared to a concurrent example. So you kind of see each of those user interactions, and you see how long it takes React to process them, but you also see those tasks broken up into small chunks, whereas with a concurrent example, the tasks are much longer blocks. So again, just kind of going back to how React processes behind the scenes in concurrency, where it's the work is, or the tasks as they're called, is broken up into small chunks and handled in small chunks, and then the browser takes back control, then React takes back control, and it's kind of just this back and forth. So I think that that's a perfect tool to use. I think React also has a profiling tool, but I would say the Google Chrome DevTools performance it basically does the job.
Sweet. And I think it's going to be our last question for today. Do you have any strategy on migrating existing codebases to new features usage? And what is your opinion about prioritise or what to refactor first, and even reasoning of that activity when there is no visible issue with performance of the application?
No, sorry, could you take the first? Could I take the first? Hear the first question again, and then I'll answer.
Yeah, I think that you can answer the last question in the Discord channel.
Okay, so what's the first part? Or do you want me to answer the first part here?
I can repeat. Do you have any strategy on migrating existing code base to new features usage?
So I haven't actually done this before in practice. I have like read about. I'm trying to think of an example. I've read about examples of people migrating code bases, but I haven't done it in practice. I think React also does have like or there's some description on how to migrate to these newer versions in detail. I can look that up and then answer this in more detail on Discord.
Okay. Thank you so much for your time.